Hello and welcome to the VCC. I'm sure that all of you are keeping fine. And today, the 17th of August, we are continuing with statistics. So I'm sure all of you are fine and learning with fun. So in the last few days, you must have completed and understood many of the important chapters of statistics, starting with data analysis and then central tendency. You have learned about mean, median, mode, and quartile deviation, and of course mean deviation, variance, and definitely standard deviation. So this was, dear friends, the basic, foundation of statistics. Today, the 17th, we are taking up probability, and in the next 3 sessions, I shall be continuing with a very important chapter other than probability, that is theoretical distribution, where we shall be covering binomial on 19th. Then 20th, we shall be covering Poisson, and 22nd, we shall be completing with normal distribution. So that is basically the game plan for today and for the next 3 days. And good to be back and good to be speaking to all of you. So today we are taking up chapter 16. So please bring out chapter 16, probability. It's a very, very interesting chapter of statistics. And apart from being interesting, it is definitely a very practical chapter. In fact, I will say the most practical chapter of statistics is probability, theoretical distribution, time series, index numbers. But then the foundation of statistics is definitely what you have done, data analysis, different types of central tendency, and so on. Now today, if you see the learning objective, today's session is on probability. Now what are the learning objectives? Why do we need to learn probability? First of all, it's a very practical subject, and as a chartered accountant, let me tell you that we use probability in almost every area of our profession, starting with accounts, financial reporting, audit, all areas of finance, financial management, and probability is nothing but chance. When we talk of probability, we talk about, say, what is the chance it is raining today? Now, all of you are from different parts of the country. Many of you have joined from outside the country in your respective places. Now, what is the probability it's raining? So, probability means chance. But when you talk of chance, you also talk about financial events. Now, what is the chance that if I take a loan, I will not be able to pay the loan? I will not be able to repay the loan. So there's a chance in every activity. There's a chance in every experiment. And therefore, probability is used everywhere in financial reporting, in audit, in financial management. And of course, I will say that probability is a very important chapter which builds up your capability to take management decisions. So, the first point I will write is, of course, on this side, I am writing down the important terms, and we are also discussing about number of formula, which I'll be noting here. But the first point which we shall note is that probability is used for decision making. Decision making. Okay? It's used for decision making by management. Now today, you are students of foundation, fine. After a couple of years, all of you will pass the exams and become chartered accountants. You'll be working in different industries. And the first industry application of probability is in the area of banking. So the first, I will say, it's decision making, but the first area is banking. Okay, now banking, bank gives loans. You have read about number of cases where people have taken loans and they have run away. Right, like Vijay Mallya, you have Nirav Modi case. So in banking, there's something which you are learning, of course, in your commercial, BCK. Now, you're learning about banking sector, you're learning about insurance sector. In banking, we always find out the probability of default. It is called PD, probability of default. Right? So what is the chance that if I take a loan, I will not be able to repay the loan? Right? You can be taking a term loan, it can be a loan for your higher studies, it can be loan to buy a flat, it can be loan to buy, for example, a car. It can be any type of loan, working capital loan. But when I take a loan, I'm supposed to repay. So in banking, we always calculate the probability of default. What is the chance that a person will not repay the loan? Now say there are two persons, A and B. A has a probability that 60% chance that he will not repay. And there is B, right? The chance of default is 30%. So the bank will prefer A or B. So A has a chance, 60% chance he is not going to pay back. But B has a chance, 30% chance he is not going to pay back. That means, you see, B has a lesser chance of default, a lesser probability of default. That is why B is preferred. So you can see, through probability, we also take decisions in banking. First. Second, of course, when we talk of, fraud, what is the chance that there will be a fraud in a company? Right? Now, you know that chartered accountants also work as forensic auditors, statutory auditors, internal auditors, and we deal with many unpleasant things like fraud as well. So there we use software to find out what is the probability that a fraud will take place in the company. So first is banking, the second is fraud, right? So let's keep noting these points. First is banking, and I showed you what type of probability we calculate. Second is fraud. Okay. The third is, in case of audit, you will be learning about audit later, but I'm sure you have got a very good idea of accounting, right? Because you should be completing your accounting in the next few days. Now, when we talk of accounting, financial statements, balance sheet, profit and loss statement, cash flow statement, different budgets, right? So what is the chance there is an error or a mistake in accounts? I'm sure you have done rectification of errors, right? So that chapter tells you that there can be some errors in accounts and we have to rectify. So the probability of errors in accounts. Okay? The fourth industrial example is defectives. Now say you are a manufacturing company. You are producing cars, you are producing handsets, you are producing any commodity. What is the chance that there is a defective in a batch of 100 items? So probability of defectives. This is very important and used in all manufacturing companies. Now we come to number 5, life insurance. Life insurance. Please see the different areas where probability is used. So you understand why I said that this is a very, very important chapter and a very practical chapter. So life insurance. There, say there's of course, you take an insurance cover and you pay premium. You have to pay a premium. It can be a monthly premium. It can be an annual premium. Okay? But then, if a person goes for an insurance cover, first of all, the insurance company finds out the probability that he is going to die. In other words, if the probability is very high that the person will die very soon, then the premium amount will be higher. Okay? So the probability of death, and this is called mortality rate. Mortality rate. So many of our friends, chartered accountants, we work in the insurance sector. We have many clients in the banking sector, in the insurance sector, and there we calculate what can be the chance of a fraud, what can be the probability of a death happening, what can be the probability that a person will take a loan and will not repay it back. Okay, so these are what we do. Next is, of course, lottery. Now, when we talk of lottery, right, it's a game of chance. So any lottery, any betting, right? Many of you have seen movies. If you have gone outside India, you must have seen casinos. Now, casinos means what? It's quick money, but then it's a game of chance. So, probability is very important in casinos, in betting, and sometimes, of course, many of you have heard that there are illegal betting rackets also. Like some people say that in cricket, sometimes there are people who indulge in betting. So when we talk of betting, of course, we talk of probability, right? We talk of chance. Then comes a very important point. So lottery and betting, the 7th point is exams, our exams. Okay. What is the probability that you will pass in CA Foundation? What is the probability that you will pass in mathematics with 70% marks? Yes, exams means chance. Exams means, well, there is some uncertainty. You cannot say for sure that yes, he is going to pass the exam. Okay, so when you have exams, you have chance. Next, of course, last but not the least is when we talk of a new product, right? Say our company is launching a new product. There is always a chance that the product will be successful or it may not be successful. Okay? You're clear? Therefore, when we talk of new product launch, that means marketing. Even in marketing, you will be surprised to know that probability is used because for launching any new product, the company puts in a lot of thoughts. The company puts in new ideas. The company gets a new brand ambassador. It can be SRK, it can be, for example, Big B, it can be anybody. Right? It can be the, say for example, cricket captain of India, Indian team. So it can be any celebrity. But then a question comes that if you have a new brand ambassador, the first question which the company asks, the management asks, yes, is that fine, I'm getting so and so for doing the brand, for being the brand ambassador, but what is the chance? What is the probability that my sales will go up? My revenue will go up? Are you following? So you can see right from banking, frauds, errors in accounts, defectives, life insurance, lottery, exams, marketing, and last but not the least, friends, in the area of risk management. Risk management. Now, in a company, for example, you hear about accidents. What is the chance that there will be a fire in a refinery? Imagine an oil refinery. If there is a fire, massive fire, oil, petroleum is flammable. So if there is a massive fire, it will lead to the loss of huge amount of property, machinery, lives. And you can understand, all refineries are having insurance cover. So if you are an insurance company and you want, I'm a petroleum company and you want to provide me insurance cover, then first question which you will be asking is, what is the chance that the fire can happen in my refinery? Right? Few days back, I think I had the last session with you on the 5th of August. Now on the 7th of August, there was a massive, an air crash in Kozhikode where an Air India Express Boeing 737 landed, and it was a huge, slippery surface, heavy rains, and there were casualties. 18 people lost lives. But normally, aviation is a safe industry. So in aviation also, many of us who work in aviation, right, we always calculate what is the probability that a crash will happen, air crash will happen. So everywhere we deal with chance, everywhere we deal with probability, everywhere we deal with, uncertainty. So many areas, right? From banking to any industry, banking, insurance, you talk about cricket, you talk about any type of lottery business, risk management, right? Life insurance, everywhere you can see that we have probability. Now we will go into we have seen the first part, that is the applications of probability, and you can just keep a note in your exercise copy that probability is used for managerial decision making. So I'm writing the first point. We have done the applications, apps, and then we have looked at the fact that it helps in decision support. Right? DS, decision support. Okay, now, of course, today we'll take up different types of probability. We need to be clear about the basic terms of probability, the basic concepts. We shall also go into conditional probability, expectations, and as usual, we shall be solving number of examples as well as questions from exercise 16A and, of course, the MTP May 2020. And I hope you're following. I hope all of you are you're carefully, you're following what I'm saying. You're comfortable, audio, video coming fine. Make sure with the knowledge you learn, my only request to you, make sure that the probability of you passing in the exams should be 1. Because in case of probability, the highest probability is 1, which means 100% chance. So that is my request to all of you. Okay, so now, what is probability? See, there are 3 terms. We can talk about likelihood or chance, right? So we talk about probability like this, the probability of an event, probability of passing the exam, probability that it's going to rain today, probability that India is going to win in the next cricket match, whenever it takes place. The probability that India will get 10 gold medals in the Tokyo Olympics next year. So everywhere we talk about chance, we talk about likelihood. Okay? So probability deals with this. And it is an integral part of statistics. If you see, I am covering 16.1. In 16.1, you will find that it is clearly mentioned, dear friends, that probability is a distinct part of statistics. It's a part of statistics. Okay, I'm writing stats. It's an integral part of statistics. And once you understand probability, the next chapter, theoretical distribution, will be clear to you. So probability is like a foundation based on which we have the next chapter, that is theoretical distribution. So, one point before we go on is, if I say that, I'm not going to pass the exams, I'm not preparing, I'm not serious, I'm not working hard, I'm not following the VCCs, okay? So if I say that I'm going to fail in the exams, in other words, I mean to say my chance of passing will be 0. That means the lowest value of probability is 0. In other words, if my probability of passing is 0, it means that it is an impossible event. Impossible. If I say that my probability is 50%, my passing the exam, the probability is 50%. This means 50% means half. Okay, so we will call it equally likely. Equally likely. Why? Because 50% chance of passing, that means 50% chance of failing. So passing and failing is same. 50% preparation. If I say that the probability that I will pass in the CA foundation exam in November is 80%. 80% means it is 0.8. Okay, so it is 4/5. So I will call it almost certain. Please see, if it is 0, I will call it impossible. Okay, impossible. I'm not going to pass the exams. I'm not working hard. I'm not putting in efforts. I'm not, preparing under exam conditions. I'm taking the VCC very casually. No chance. I don't have a chance. I'm waiting for the next year. Or if I tell myself that, oh my God, horrible, 2020 is horrible, COVID, so many accidents happening, we have lost so many well-known superstars in Bollywood, this year is bad, this year is awfully bad, I'm not going to pass. So I'm saying probability is 0. It is impossible. So when the probability is 0, we say that it is an impossible event. Here the event is me passing the exams. Okay, so impossible event. If I say probability is 50%, right? Probability is 50% means, yes, equally likely. Yes, I may pass, I may fail, and they are equal. Both are 50%. If I say that, yes, I am putting a lot of efforts, right? I am really working hard. I am trying to complete all questions under exam conditions. I am following the VCCs. I am going through the additional question bank, and 80% chance I will pass. If I say that, yes, I will call it almost certain. And if you are in such a position, and if you say that I am 100% certain of passing, no one can stop me, right? I have gone through the highest level of preparation. I am putting in the maximum hard work, and there is no chance that I will fail. If I am physically fine and mentally fine on the day of the exam, I will pass with flying colors. If you are so confident, well, God bless. If you are so confident, very good. That means you are saying that your passing, your chance, probability of passing is 100%. 100% means 1. And this we call a certain event. Certain. So dear students, dear friends, you can see the probability, the lowest value. Why I am taking this example is to show you that the lowest value of probability, right, if I write the lowest value, so the lowest value of probability will be 0, and it has to be less than equal to 1. So the lowest value is 0, and the highest value of the probability is 1. In other words, probability is a fraction. It lies between 0 and 1. Okay? So it is more like a fraction. That means in all the examples, in all the exercises, the numericals we shall be solving, you will find that the answer will always be a fraction. We shall never deal with negative probability. You cannot have minus, say for example, minus 3 by 5. You cannot have it. You cannot have a probability of 5.4. No. Probability will lie between 0 and 1. As I said, if I fail in the exams, that means if it is impossible for me to pass the exams, P equal to 0. Impossible. If it is 50%, equally likely. If it is 80%, well, almost certain. And if it is 100%, that means I am sure of passing. Sometimes, very curiously, there's a saying in English that once you are born, once you come to this earth, once you are born, there are two certain things. Two certain things. What are the certain things? First, if I'm born, we are all born. So the two certain things in life are that we shall die, and second is we have to pay tax. These are the two certain things. So certain means from the statistical point of view, from the mathematical point of view, certain things means 100% probability. So if somebody is born, 100% chance that the person will die someday, and maybe a equally high chance that he has to pay tax. Of course, he has to pay tax, whether direct tax or indirect tax. Okay, so this is basically what is probability. It is nothing but a chance that something will happen, right? Probability is used in so many industries, right? And some of us, who work in different sectors, like I work a lot in the banking sector, in the aviation sector, in the insurance, their probability is very, very important for us. In audit, probability is very, very important. And you can see that the maximum value of probability is 1, positive 1, plus 1, and the lowest value is 0. So probability cannot take any negative values, and probability of an event cannot be more than 1. I hope it's clear so far, right? So we have discussed about the applications of probability. We have seen that probability helps in decision making in different industries, and then we saw the definition of probability, plus we saw that the minimum is 0 and the maximum value is 1. So this is what we have done so far. Now, question comes, of course, that if we are talking a lot, so much about probability and the fact that probability is such an important topic for us. Who is the inventor of probability? Who started probability? Now there are many experts who started the idea of probability. First of all, we have Simon Laplace of France, who was one of the experts to bring the idea of probability. Next, we have Thomas Bayes. In fact, there's a theorem which is called Bayes' theorem. Bayes' theorem. I think it is not there in your syllabus, but we have learnt, Bayes' theorem. I had a science background, so before I took up CA, so we learned about Bayes' theorem. Right, Bayes' theorem. So Thomas Bayes is one of the founders of probability. We have Laplace, one of the founders. Then we also have Fisher, a very well-known mathematical expert, R.A. Fisher. So he's from England, and he was one of the first to start the idea of probability. And we also have Kolmogorov. Okay? This is R. Kolmogorov is from Russia. So you have France, you have England, you have Russia. 4 experts: Laplace, Thomas Bayes, R.A. Fisher, and you have Kolmogorov. In fact, in different areas, even in physics, in science, in chemistry, in nuclear physics, you have probability applications. Most important practical part of statistics we have started. Okay, so this again you need to know about probability, who are the founders. Now we come to some terms, important terms, and we shall understand each of them. Okay, now first term we will understand is what is an experiment. Then we shall see that every experiment has an outcome, which is also called event. Okay, so now we are taking up the terms. So inventor we have discussed, and now the terms. Okay, now say I have a coin. I have a 2 rupee coin here. Being visible? Yeah. So coin. Now I'm just want to toss the coin. Right, let's see. Okay, fine. Oh, it's heads. Now whether it's a head or tail, right, if a coin is tossed, there are 2, outcomes which can happen. This flipping of the coin, once again, flipping of the coin is an experiment. Okay, so experiment is coin tossing. Coin tossing is an experiment. What is the outcome or the event? What is the event? What is the outcome? Either you will get head or you will get a tail. So this experiment has 2 outcomes. Okay, so with respect to a coin, 2 outcomes. Now I can say that experiment is an operation that has an outcome. So I can write that experiment is an operation which gives an outcome, or it gives an event, outcome or event. Fine? The maximum, of course, the probability. The maximum probability is 1, the minimum probability is 0, and in case of coin, what is the probability of getting a head or getting a tail? I'm sure you can answer this, right? The answer is half, because there are the two possible outcomes, right? 2 possible outcomes. It can either be a head or it can be a tail, either a head or a tail. Therefore, the probability of getting a head is 2 outcomes possible, and if it is head, that means 1 by 2. The probability is half, 1 by 2. Similarly, the probability of a tail would also be 1 by 2. Okay, so the tossing of a coin is definitely an example of an experiment. So in the terms, first we have talked about what is an experiment, and we have seen what is an event or an outcome. Okay, now I have another, some of you might be playing so many games, indoor games in the last few months. You could not go out. everybody is confined within your home, and therefore indoor games. We are missing the field, we are missing, soccer, we are missing outdoor sports, missing cricket. But now we have to be happy with indoor sports. Indoor sports, yes, we use this dice, So I'll just try to throw the dice and see if I can get a 6. Okay, so let me see what happens. Okay, oh, I'm sorry, I got a 4, not 6. Now the chance in case of a dice, now if I throw a dice, well, is it an experiment? Throwing a dice, I have two die here, 2 dice. One is a small one, the other is a big one, bigger. Okay, so when I throw a dice, is it an experiment? Yes, it is an experiment. It is a random experiment and it will give you some outcome. So, this was the outcome in case of coin tossing. Now, if I just remove this and if I just say that when I throw a dice, so the experiment now is throw a dice. In case of a dice, if you throw the dice, what are the possible outcomes? Okay, so you can get 1, you can get 2, you can get 3, 4, 5 or 6. So you have 6 outcomes. Okay, so if I ask you that if you throw a dice, what is the probability that you will get 3? Okay, that means I have how many outcomes? I have 6 outcomes, but I need 3. That means out of this 6, I only need 3. Okay, so therefore my probability is 1 by 6. If I ask you that when you throw this dice, okay, when you throw this, when you throw this dice, okay, when you throw this dice, say, just drawing, when you throw this dice here, question is, what is the probability that you will get a number which is a multiple of 2? Okay, so what is the probability that if you throw this dice, okay, this dice, if I throw the number which comes up, okay, it will be a multiple of 2. That means there are 6 possibilities, okay, 6 possibilities, 6 outcomes, okay, like when I appear for an exam, 2 outcomes, I may lose, I may fail or I may pass. When I throw a coin, okay, I'm throwing a coin, you can have head or you can have tail, right, 2 outcomes. But when I throw a dice, when I'm flipping a coin, 2 outcomes. When I'm throwing a dice, there can be 6 possibilities, 6 outcomes. So we have 6. But now the question is, what is the chance, what is the probability that the number which comes up is a multiple of 2? That means the possible favorable, the favorable number for us is either 2 or 4 or 6. Because the question is, the number which comes up should be a multiple of 2. I hope you are following, dear friends. You are understanding the way I'm trying to explain, and I'm sure it's clear to all of you. So, when I'm just throwing a dice, the chance of getting 3 is 1 by 6. The chance of getting 1 is 1 by 6. But when I'm saying that the number which is going to come up should be a multiple of 2, then out of the possible outcomes, I have 2, 4 and 6. That means out of 6 outcomes, I have 3. So my favorable outcome is 3 and my possible outcome is 6. So please remember, probability means it's a fraction and we find out the favorable outcomes divided by the possible number of outcomes. So please note this, favorable by possible. Favorable number of cases divided by the possible number of cases. In this example, yes, the number of cases are 6 and the number of favorable cases, of course, is 3. So the probability is 3 by 6, which means it is 1 by 2, half. 50%. Okay, so we have discussed, dear friends, about experiment, and we have also seen the formula. So what is experiment, what is event, and we have seen the probability formula. Okay, now it's time to move on, and I hope now you can understand that probability is the mathematical way to find out what is the chance that an event will take place, what is the chance that any random event takes place, any experiment, a random experiment. Example is throwing a coin, appearing for an exam, throwing a dice, right? An aircraft taking off, anything for that matter. A child is born, right? So any event, any experiment that way, an experiment, it can have outcomes. For example, a child can be male or female. So two possibilities. In case of coin throwing, we have either a head or a tail. In case of dice, we have 6 possibilities, 1 to 6. So everywhere there are some outcomes, and probability means the ratio, the fraction, where the denominator gives you the number of possible cases and the numerator gives you the number of favorable cases. So favorable cases divided by the number of possible cases gives you the probability, and the probability maximum value can be 1 and the minimum value can be 0. But you must always target so that you pass the exams, you become a chartered accountant, and for you the probability should always be 1. So always strive for sure and certain. Okay. So now we go into some more, experiment and their outcome. I gave you some examples. Random experiment. Yes, throwing a dice is an experiment. Flipping of a coin is an experiment. Now, say I am in the industry and I am, say the company where I am working is manufacturing bulb. Okay, LED bulb or any type of incandescent bulb. Now, when I'm inspecting, say the finished goods are here. This coming out in an assembly line. The finished goods are coming out. I will pick up a bulb randomly and test it. So this picking up of a bulb and testing the bulb is an experiment. It is an experiment. What will be the outcome? Every experiment has outcomes, and the outcome is also known as event. Okay? So when I am picking up a light bulb, there are 2 possibilities, 2 outcomes. It can either be regular, that is working condition, or it can be a defective. So 2 outcomes. Now, say you have fever, right? God forbid anyone having fever during these, bad times when there is absolutely no certainty of life. So many near and dear ones are getting, we hear news every day that people are losing their lives in COVID. And COVID is not sparing the rich. COVID is absolutely indifferent. Whether you are rich, you are poor, you are a minister, you are a movie star, you are a sports star, you are a politician, right? So nobody is spared. But definitely the probability of death has gone up. I'm using mathematical terms. The chance of a person dying has gone up. Now say somebody having a light fever and, cough, like this cough, dry cough, bad. When I go for a swab test, COVID test, 2 outcomes. Going for a COVID test is an experiment. It has 2 outcomes. Either I am COVID negative, which I will always pray for, or unfortunately I am COVID positive, which means 14 days of quarantine, which means a lot of headache. So going for a COVID test is an experiment. It has 2 outcomes. Okay, you are purchasing a share. Okay, you want to invest in the stock markets. Many of you or your family members might be spending money and, they might be buying shares. When you buy a share, it is an experiment. What are the outcomes? Either after buying the share price will go up, or the share price will come down, or the share price will be static. So when you buy a share, 3 outcomes. Either it goes up, or it comes down, or if the price remains the same. So purchasing inspecting a light bulb, going for a swab test for COVID, these are experiments. Now, some of you who are also, maybe you are very conscious about your diet, the food you eat. Some of you are into sports. You are actively involved in sports. Like I'm also into sports, right? So question is, when you are into sports, we follow a very careful diet. So following a diet, what you have for breakfast, what you have for lunch, right? No carbohydrates, no excessive carbs. So this diet, if I follow a diet, it is an experiment. It has two outcomes. Either after following the diet, I will gain weight, become, healthier, or I will lose weight. And in some circumstances, little chance that, the probability may be very low that your weight remains the same. You may remember that before the movie Dangal, Amir Khan actually gained weight. Why? Because he had to perform the role of a senior this character was such that he had to put in weight. He was supposed to be a father in that movie. So he gained weight. So when you are having a, diet, when you are experimenting with a diet, it is definitely an experiment. It has two outcomes. Either you gain weight or you lose weight. Outcomes are two. When you appear for the CA exams, yes, of course, two outcomes. Right? Some people always say that after May, there's always November. And after November, always May, so don't lose hope. But definitely true, when we appear for the exams, appearing for an exam is an experiment. It has two outcomes, passing or failing. Right? Somebody is standing for the elections. 2021, next year, elections in many states of India. Right? So when you stand for the elections, standing for the election is an experiment. Outcomes can be two. Either you win the elections or you lose. Last example. I'm giving so many examples so that you can understand what is experiment and what is outcome or event. Okay? So I talked about light bulb, for example, testing of light bulbs in a factory, going for a swab test during this COVID pandemic times, purchasing a share, following a diet, appearing for the CA exams, then standing for the elections, and lastly, when you buy a new car, for example, or when you buy a new handset, right? You buy a new handset with your pocket money, or your father or your mother presents you a new handset on your birthday, and also for listening to the VCCs of the institute. So for the online training. Now, when you buy a new handset, you have two outcomes. Buying a new handset, is it an experiment? Yes, it is an experiment. How many outcomes do you have? Either you are happy with the handset, that it works, it is fast, it's 6 GB RAM, super fast. I'm a poor fellow, I have got, say, 2 GB RAM. My father has provided me a gift, 2 GB RAM. Not good. You have got a 6 GB RAM. Okay, and say the storage is, say something like 128 GB minimum. Right, I have got 32 GB and 2 GB. So, of course, when you buy a new handset, buying a new handset is an experiment, two outcomes. Either you are happy, that means the handset works up to your expectation, or you are unhappy, which means the handset does not provide you value for money and you are not happy with the performance of the handset. Okay, so these are experiments and these are outcomes. I'm sure now you are absolutely clear with experiments and outcomes. So dear friends, with this, let's move on to some of the other important terms, and these are very, very critical terms, dear friends, because if we are not clear with these terms, we shall not be able to solve numericals and other questions which can come. So we have talked about experiment, events and outcomes, and I have also given you number of examples. So I'm just completing each and every section and keeping a note of it so that at the end we can see what are the areas we have covered. Okay, now we go to a very important definition now, a very important term, and that is, now you know what is an event or an outcome. Every experiment has an outcome or an event. Now, we go to a very important term, mutually exclusive. What is a mutually exclusive event? We will also go into, first let's take mutually exclusive, very, very important. So terms, we have started with terms. First we are taking mutually exclusive, then we shall take equally likely, and we'll take exhaustive. Okay. First is mutually exclusive. Now when I throw I throw a coin once again, let's see what comes. So tail this time. Fine. Now, when I throw a coin, you can have two outcomes. Either for a coin, either it's a head or it's a tail. Can both of them take place together? In other words, when I throw a coin, can I have both head and tail? I throw the coin once. Can I have both of them together? No. That means if I have a head, automatically it means I have not got tail. I have got a head. Right? So, when you talk of mutually exclusive, it is also known as incompatible. Incompatible. Incompatible events. Right? Incompatible events. Which means that if you have, now say I'm going for another example, I'm going for breakfast. Right, I tell my mom that, today is Sunday, can I have something special for breakfast? Oh, she gives me, she prepares a delicacy. Say I love South Indian food, so if I say, can I have a lovely dosa or a lovely, a platter of idli, for example, or uttapam, fine. So, I have choice, say a North Indian dish and a South Indian dish. Now, when I go for a South Indian dish as my breakfast, eating breakfast is an experiment. I have two outcomes, right? I have two choices, North Indian and South Indian. Today I'm in the mood to have a South Indian meal, right? Now, when I go for a delicacy from the South, it means what? It means that if I have a South Indian dish, I cannot fill my stomach with a North Indian dish. That means this is also mutually exclusive. If you have North Indian dish, fine. That means you are not getting South Indian. You have got a North Indian dish. Similarly, when I am getting head, it means I have not got a tail. So these are mutually exclusive, which means that if you have one event occurring, then it automatically means that the other event cannot occur. If I say that I have passed the exams in CA final, that means I have not failed. I have passed. So passing means not failing. Please remember, these are called mutually exclusive. Mutually exclusive. They will never have a common point. They will never intersect. They are totally different. Passing, failing. Nothing in between. Either you are successful in life or you are not successful in life. Nothing between. Either you become a CA or you fail. Nothing between. Right? I hope you are getting it. Either you become a superstar or very few superstars are there, or you are just an actor. Nothing between. So these are mutually exclusive. When I am throwing a dice, and if my target is to get a 6, if I get 6 on top, it means that I have not got 3. So getting 6 means that it's 6 and I have not got the other numbers. So occurrence of a 6 means non-occurrence of any other number. For example, 4. Right? So this is called mutually exclusive. I'm spending time on this so that you are clear. Now, when we show mutually exclusive events or incompatible events, right? I'm showing it in the Venn diagram. Please see that we have done Venn diagrams. I'm sure you remember I've done Venn diagrams with you earlier in the chapter on functions, sets and, you might be remembering relations, right? Now, when we draw a Venn diagram, let's see what will be the picture. Okay, so I'm trying to draw a Venn diagram. Two events A and B. Okay. The event A is passing in the exam. A is pass and B is fail. Can they happen together? That means in the same exam, can I pass and fail together? No. Can I pass and fail together? No. So you see, these are disjoint. We call it disjoint. Disjoint. That means they are not linked. They are separate. Why? Because they cannot happen together. They are separate. Okay? You cannot have both of them together. I cannot have say for example, a tandoor dish with a South Indian delicacy for breakfast, provided that I will be eating my normal, quantity. I can opt for any one. I cannot have both. I want to see, I go to a multiplex to watch a movie. I have a choice of an English movie, a Hollywood thriller. I have, say for example, a latest Bollywood movie. Now, if I buy a ticket, going for a movie is an experiment. I have two outcomes. Watching an English movie, watching a Hindi movie. I cannot watch both together. It's not possible. So either if I go in and join the English movie, that means occurring of the English movie means non-occurrence of the Hindi movie. I cannot watch Hindi movie at the same time. So they are mutually exclusive or incompatible. Right? I hope you are following, dear students. Right? And I hope things are getting clear to you. So it's very, very interesting and so many new concepts to learn, so many new terms we are able to add to our, in our brain, in our mind. So this is in Venn diagram. These are called disjoint. Please take a snap of this and keep it. It's not there possibly in the study material. Disjoint. This is disjoint. Now a very important relation comes. I can say, you remember that in case, can I say that in case of mutually exclusive events, A union B, can I write in this way? A intersection B is 0. Can I write? Please check. A and B, do they have anything in common? No, they are mutually exclusive. They have no common parts. So A intersection B is 0. So a very important formula. Now we write the first formula. Formula number 1. The chance of passing and failing. Right. So let the probability of passing be PA and the probability of failing is PB. Two events, two separate events. Right. Now what is the formula for A plus B? PA, A plus B. So the formula for two events which are mutually exclusive is PA plus PB. So please keep a note of this. PA plus B. So the first formula I am also keeping a note. PA plus B equal to PA plus PB. So this is the formula for the probability of two events. The sum of the probability of two events. Right, two events. We are trying to find out A and B. So A or B. Right. So there we use the simple formula PA plus PB. Why? Because since A intersection B is 0, that means we can write probability of A intersection B is 0. Therefore, PA plus PB. So this is the first formula. Please note, this is only for mutually exclusive events. Now I am taking up non-mutually exclusive events. So this was mutually exclusive. Now we are taking up non-mutually exclusive. So dear students, I hope you are clear with what is mutually exclusive. Now we are taking up non-mutually exclusive. Okay. Non-mutually exclusive events means that there are two events where there can be some common points. There can be some intersection. So in that case, if I draw, what will happen is like this. Let me just draw the Venn diagram and we will see how it will look. So in case of two events which are not mutually exclusive, it shall be like this, A and B. And there is a common point. This part is A intersection B. Now, what can be an example of these are non-mutually exclusive? So, non-mutually exclusive. It is not mutually exclusive. Non-mutually exclusive events. Now say, I am giving an example like this, that say, I am taking two numbers, two sets of numbers. Okay. Say, I am taking a set A, which has the numbers 2, 4, 6 till 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it's it is a multiple of 2. I have set B, which has the numbers 4, 8, 12 till 20. These are the two sets. Now, if I tell you that you have to choose a number such that it is either a multiple of 2 or a multiple of 4. Please note, these two events, choosing a number, A and B, are they mutually exclusive? No. Because if you write A, if I am just expanding A here and I expand B here. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Fine. I also expand B. B is 4, 8, 12, 16, 20. My question is, if I want to find out whether they are mutually exclusive or not, you can see out of these numbers, there are certain common numbers. 8, 4, 12, 16 and 20. That means these two sets are not mutually exclusive, which means in this example, the two events which you see here are not mutually exclusive. In this example, if you are asked a question that for these two events, if you have to find out PA plus B, then the answer will be, please note, PA, probability of A, plus the probability of B, minus the probability of A intersection B. So please keep a note of this formula. The same formula which we have done for set theory. The same formula. No change. PA plus PB minus probability of A intersection B. So PA, the full A, PA plus PB, the full of B, minus this part. So please note, this is for non-mutually exclusive, non-ME, mutually exclusive. This is only for non-mutually exclusive events. Okay? Now we move on to the next concept. So I hope it's clear about what is exclusive, mutually exclusive events and what is non-mutually exclusive events. For mutually exclusive events, PA plus B is equal to PA plus PB. For non-mutually exclusive events, PA plus B is equal to PA plus PB minus PA intersection B. Okay? I hope this is clear to you. PA plus PB minus P intersection B. Okay. Now we move on to exhaustive. What is the next concept? Next idea is exhaustive events. Okay. So these are easier ones. Exhaustive and equally likely. So exhaustive. What do you mean by exhaustive events? Exhaustive events means, say I toss a coin, head or tail. That means exhaustive means when I write head or tail for tossing a coin, these are exhaustive, which means these are exhaustive events, which means that there cannot be any other outcome. Mutually exclusive means what? Either it's a head or a tail. You cannot have both. Either I fail or I pass. Either I am happy with my marks or I am not happy. Either my product is successful in the market or not successful. So, either or. mutually exclusive. Exhaustive means that other than head or tail, there cannot be any other outcome. That means it says that the total probability that having a head or having a tail together is 1. Total probability will be equal to 1. Probability of the event equal to 1. So exhaustive events means that when you carry out any experiment, one of them has to occur and no other event outside head or tail can occur. So if I say for a dice, when I throw a dice, the sample space is what? 1, 2, 3, 4, 5 or 6. This entire, each of them is an outcome. You can have 1, you can get 2. When you throw a dice, you can get 3, you can get 4, 5 or 6. So each of them is an event. You have 6 events, 6 possible events, 6 possible outcomes. Are the events exhaustive? Answer is yes. For example, when you throw a dice, you cannot have 0. You cannot get 8. You cannot get 7. You can get 1 to 6. Therefore, 1 to 6, this sample space or this event, this set of event is exhaustive. Right? So I think now we have understood what is mutually exclusive. We have understood what is exhaustive. Now we see what is the last one, equally likely. What do you mean by equally likely? So I have explained earlier about equally likely. One more example I am taking. So equally likely. Very simple. Once again, throwing of the coin, head or tail. Okay. Head, fine. So when you throw a coin, what do you get? So question is, you get 2 events, 2 outcomes. Either it's a head or a tail. So when you throw a coin, when I'm throwing a coin, I have 2 outcomes, head or tail. The chance of getting a head is half. The chance of getting a tail is also half. That means they are equally likely. Both are equal. 50-50 chance. Okay. When I am throwing a dice, right? I am throwing a dice. Okay. Whatever number I get, the probability is 1 by 6. Why? Because there can be 6 possible outcomes. Therefore, dear friends, equally likely means when the events are symmetric. So, this equally likely term which you see is also known as symmetric. Okay. So, they are also known as mutually symmetric events or they are equiprobable. Fine. Please note. Kindly note it in your scrapbook. So equally likely, symmetric, and we have equiprobable. They are the same. That means each of them has the same probability. Okay. Now we understand what is sample space. Okay. Last one. So we have seen mutually exclusive, exhaustive, and equally likely. Now we see what is sample space. I know you are all aware about sample space, because we have discussed it last session when we did, the sets and relation. Sample space. Okay. Sample space means the totality of all outcomes. Please note this. One line, a simple definition, right? Sometimes in different materials you will get one paragraph. Very difficult to understand. I am giving you a shortcut. Simple one line definition of sample space. Totality of all outcomes. Outcomes of what? Of an experiment. Of an experiment. Okay. So we are talking about sample space also. A plus PB minus PA. We are talking about sample space also we have taught. Sample space. Now what is sample space? Question is, if I am throwing a dice. Okay, so first one, dice. I am throwing a dice. My sample space means it is a totality. Totality means it's like a matrix, an array of numbers or a group of numbers or a set of numbers, right? So I draw a set notification here. If I throw a dice, what will be the outcomes? It's an experiment? Yes, throwing a dice is an experiment. What will be the outcomes? Possible outcomes 1, 2, 3, 4, 5, 6. I close my set. This which you see here is sample space. This is a sample space. Okay? And the probability of sample space, if I denote the sample space by S, the probability of sample space is 1. Because if I add up all the probability, it will be 1. Each of them 1 by 6. But there are 6 possible outcomes. So 1 by 6 into 6 is 1. Okay. So therefore, you get probability of the sample space is always 1. Fine. So therefore, we have seen probability. It is a chance. It is also known as likelihood of an event occurring. Right? We have seen what is an experiment. We also discussed about the fact that experiment has outcomes. Experiment has events. And then we took up, examples of different type of experiments. Then we looked at the terms, mutually exclusive events, equally likely events. Then we have also talked about exhaustive events and sample space. Plus, we have seen two formula. One is for mutually exclusive events where PA plus B equals PA plus PB. And for non-mutually exclusive events, PA plus B equals PA plus PB minus PA intersection B. Okay? So this is what we have done so far, and now we enter into the further, discussion of events. Now we see what is complementary event. Okay? Complementary event. So sample space, I think you are clear. Now we look at what is complementary event. So probability, if you see the formal, Laplace definition, you see the formal definition, or sometimes called the a priori definition, right? Now this actually means probability of an event A, PA, is equal to the number of mutually exclusive, exhaustive and equally likely events which are favorable to A, favorable to A, divided by total number of mutually exclusive, ME, exhaustive and equally likely events. So this is the formal definition, and it is also called the a priori definition, and we are really indebted, we express our gratitude to two great minds. One of them is Bernoulli and the other is Laplace for giving us this equation. And as I said, as a chartered accountant, working in different industries, which I do, I use this definition of probability and the probability techniques almost every day in my professional work. It is not a chapter to study in mathematics. It helps us a lot in solving complex business problems in our clients. Okay, so you have a priori definition, number of favorable events, number of possible events. Fine. Now we go to what is a complementary event. Okay, so please keep a note of this. A priori definition also I'm writing. We have completed this. What is the a priori definition? Fine. Now we look at complementary event. Okay. Now if I say that the chance, probability of rain, the chance that it's going to rain today, say is looking outside, it's quite sunny. So a chance of having rain in the evening maybe is say 15%. Probability of rain. So PR is 15%. That is 0.15. So if I ask you, what is the complementary event? What is the probability of the complementary event? So here, complementary event. will be shown as R is the event. R is the event for rain. So the complementary event will be shown as R dash. And probability of the complementary event, PR dash will be 1 minus probability of the event. PR is 15%, so the complementary event probability is 0.85. So please see once again, I have taken the chance of rain today. Here in Kolkata today it's reasonably sunny, so I have taken a low probability of rain, 15%. Okay, so I have taken 15%, 0.15. Complementary event as of now, that means based on this probability comes to 1 minus PR, that is 0.85. Please remember a simple formula based on this. Now, PR, probability of event R, plus PR dash, please note, will always be equal to 1, has to be equal to 1. So please note this formula, that probability of an event and its complementary event, the probability of an event occurring plus the probability of its complementary event has to be equal to 1. PR plus PR dash will always be 1. Fine? Please note this. Okay. So I am keeping a note of this, that complementary events, we have discussed about complementary events and this important formula as well. Complementary events. Fine. Okay. Now we also take one more before which we will then we will start moving into problems and examples. So the last one is, sometimes you get a numerical like this, that the odds in favor, right? So if it is given that the odds in favor, odds in favor of passing the exam, of passing CA exam for a particular person, okay, say it is given, say is given 3 to 5, odds in favor of passing an exam is say 5 to 8. Okay, the odds in favor of passing the exams is given as 5 to 8, which means that the odds in favor of A will be how much? Odds in favor will be 5 divided by 5 plus 8, that is 5 by 13. Okay, 5 to 8. And odds in favor means odds in favor of passing. So the probability of passing, probability of pass will be this. And odds against A. So this was odds in favor. And the odds against. That means the probability of failing. Probability of fail will be 1 minus 5 by 13. That is 8 by 13. Okay, so this is what is called odds in favor of an event and odds against an event. Okay, so if you get such a problem, this is how you have to find out what will be the probability of the event occurring and what is the probability that the event does not occur. That means the complementary event has taken place. Okay. Now we go to illustrations. I will request you to take up illustration 16.1. We'll first look at few illustrations, then we will go into numericals. Okay. Complementary events we have done and odds also we have done odds. Now we take up 16.1. Example number 16.1. We will take around 5 examples and then we move on comfortably into the questions. The first question, 16.1. A coin is tossed 3 times. What is the probability of getting 2 heads? And the second part says, what is the probability of getting at least 2 heads? Now, a coin is tossed 3 times. Okay? Coin tossed 3 times. What is the probability of getting 2 heads? Now, dear friends, at this stage, let us use the concept of sample space. If you toss a coin 3 times, what can be the sample space? Okay. It can be, let's take head, 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 H, 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 H. It can be head, head, tail, H, H, T. It can be head, tail, head, H, T, H. It can be head, tail, tail, H, T, T. T, H, H, T, H, H. THT, tail, head and tail. It can be tail, tail and head. So T, T and H. And finally it can also be the last tail, tail, tail. T, T, T. So this gives a sample space. Now let us see how many we have been able to find. 1, 2, 3, 4, 5, 6, 7, 8. I am getting 8 possible options. Now the question is, 2 heads. In how many probability of getting 2 heads? So we have to find out 2 heads. So what is the formula probability? You know it's a fraction. First, in the denominator we write the total number of possible cases. The numerator we will write total number of favorable cases. So it is nothing but a ratio of favorable cases to the possible number of cases. Correct? I hope you are following. I am saying something which you can really understand. No gap in communication, I hope. Okay. So let us see the formula and let us see the solution to this. So I know that there are 8 possible cases. So the probability of getting heads, 2 heads, equal to, denominator is 8 because we have got 1, 2, 3, 4, 5, 6, 7, 8, 8. Out of them, I need those cases where there are 2 heads. So 2 heads, if you see, I am getting how many? Let's have a look at the number of heads. 2 heads, okay, tail, head, head. Yes, 1. Head, head, tail. 2. H, T, H. Head, tail, head. Any other? No. So I am getting 3 favorable events and the total number of events is 8. So my probability is 3 by 8. So the answer is 3 by 8. Fine. So this is the first example, first part, the probability of getting 2 heads. Now the second question says, what is the probability at least 2 heads? So I am tossing a coin 3 times. What is the probability that I will get at least 2 heads? Now at least 2 heads, let's see. The same formula we are using, probability of heads, but it is at least 2 heads. Total number of cases remains the same, 8. Total number of events, in other words, remains 8. Now at least 2 heads means what? You can have 2 heads, you can also have 3 heads. Okay, now 2 heads we have already got. 1, 2, 3. So I write 3. I have to add the number of cases where we have got 3 heads. H, H, H. So H, 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 only one possible outcome. So 3 plus 1, that is 4 out by 8. Okay. So this is half. Probability is half. So the second part of the solution is like this. So you have possible sample space. Okay. Out of them you get 8 outcomes which are possible, 8 events which are possible, which are equally likely and mutually exclusive in nature, exhaustive in nature, and out of these 8, in this particular example, 4 of them are favorable. They are favorable to the event A because the question says that in how many cases you will be getting at least 2. At least 2 means it can be 2 heads, it can be 3 heads also. Okay, so we have added both the opportunities, both the possibilities, and we have got 4 by 8. Fine. Now we take example number 4, and this is on cards. Okay, so let's take number 4, 16.4. Fine. We are taking up 16.4. Now, the question is, what is the chance of picking a spade or an ace, not of spade, from a pack of 52 cards? Now, dear friends, card questions, playing cards. Many of you play cards. Many of you know, those who play cards, there are a pack of 52 cards because there are some of you, the probability is that some of you play cards. All of you definitely do not play cards. Some of you may not be knowing the composition of a pack of cards. Now, some questions on cards definitely can be expected in probability chapter as well as in permutation combination chapter. Now, when you have a pack of cards, right? So you have a pack of cards, a pack of 52 cards. Please keep a note of it because this will be helpful for solving questions. Out of these 52 cards, what do we have? We have 13 spades. We also have 13, apart from spades, we have 13 hearts. Heart sign. You have 13 clubs. 13 clubs. And we also have 13 diamonds. Okay. 13 diamonds. So please keep a note of this. So from 52, a pack of 52 cards, there are 13 spades, 13 hearts, 13 diamonds, and you have 13 clubs. Fine. Now, each of these groups of 13 cards has an ace. Okay. So there will be one ace for these 13 spades. There is one ace. Okay. One ace for this 13 hearts. One ace is for these 13 clubs. And again, you have one ace for this 13 diamonds. Clear? Okay? So 52 cards, 13, 13, 13, 13. For each of the 13, there is an ace also. Of course, the ace is included in these 13 cards. Now the question, if you see 16.4, a very interesting question, and I am once again very, very thankful to the Board of Studies for giving, and our experts in the Board of Studies who have created these wonderful questions, really grateful to them, appreciate their efforts, so that they have actually done a fabulous work. And to be very honest, right, I can say this, that possibly you don't have to follow any other textbook. The study material possibly is more than enough, because you have all types of problems, you have a number of exercises, you have number of questions in the additional question bank. For example, in the chapter on probability, you will find questions given under 3 sets, set A, B and C. Same for theoretical distribution. So wonderful questions, and this again will help you to solve questions on cards. So when you have a pack of 52 cards, you have 13 spades, you have 13 clubs, 13 hearts and 13 diamonds. Each of them has an ace. The question is, what is the chance of picking a spade or an ace not of a spade from a pack of 52 cards? Fine. So please note, I have to pick up either a spade or an ace, but the ace will not come from spade. Please listen carefully and please note carefully. Many of you, I have seen when I have explained also, many of you, maybe you had difficulty when you went through the example. The example is solved. Maybe you had difficulty. That's why I am taking up all these cases. It is there in the study material. Still I am repeating, I am explaining. In the study material it is documented, it is written. But here I am explaining. Okay, so this will help you to understand. And this type of question can be expected. Some of you who do not play cards, maybe you don't know, it's natural that you may not be playing cards. So maybe you don't know what is a spade or what is an ace. That's why I am explaining. Now, your question given here says that you need to pick up a spade or an ace which is not taken from a spade. That means 52 cards. So if you pick up one card at random, how many ways are there in which you can pick one card? Definitely 52 ways. So the probability will be like this. The total number of cases, possible cases is 52. This is the denominator, 52 here. Now I need to find out the probability of picking a spade. How many spades are there? 13 spades. So I am writing 13. I can pick up a spade. or an ace, but the ace should not belong to the spade. Here you see there are 4 aces. Ace 1 for 13 spades, ace 2 for 13 hearts, ace 3 for 13 clubs, and you have ace 4 for 13 diamonds. But I cannot pick a ace from the spade, so this is not allowed. Which means I can pick either this one or this ace or this ace. So I have 3 opportunities. Plus this 13. So it is 13 plus 3. The total number of cases or the total number of outcomes or the total number of events which are favorable to me as per the question in this 16.4 example is that either it's 13 and it is 3. 13 plus 3. So I am getting the probability gives me it is 16 by 52. I think it goes by 4. So it gives me 4 by 13. So the probability is 4 by 13. I hope you are now clear. Please have a look at the problem once again. Please see the solution in which I have arrived at the answer. And please note how the cards are actually constituted. So 13 hearts, 13 spades, 13 clubs and 13 diamonds. Each of them has an ace. Fine. So this was 16.4. Okay. Now we take up some more formula and then we will carry on with the examples. Okay. So I'm rubbing this off. 16.4 is done. Okay. Now we take some more examples. Okay. So just keeping a note 16.1 and 4. Okay. So we have seen that when there are the formula like this once again, A plus B, PA plus B for mutually exclusive, ME. Please remember, for mutually exclusive events, the formula PA plus B is PA plus PB. If it is not mutually exclusive, then it is PA plus PB minus PA intersection B. Please remember this. Plus, if there are 2 events, A and B. Now, we are covering, the formula which are given. If you see the formula in the study material, 16.10, 16.11, 12, 13 and 14. Very nicely in the chapter on probability, in other chapters also, formula numbering is given by the institute, by the board of studies. Very helpful for you to note down the formula. Okay. So, please see the formula 16.10, 16.11, 12, 13 and 14. So, this one is for mutually exclusive events. This is for not mutually exclusive events. Another important formula, if I say that A and B are exhaustive, if I say that A and B are exhaustive, that means PA plus B, or if I write PA union B, has to be equal to 1. So this is another important formula, please keep a note. Okay. Similarly, if you have 3 events, A, B and C, say there are A, B and C, 3 possible events, which are also equally likely, then we can write that PA equal to PB equal to PC, and together they will become 1, because A plus B plus C will be equal to 1 and each of them is equal to each other. So their individual probability is 1 by 3. Okay, please keep a note of this. Together they are 1, each of them are equal, which means 3 equal parts, right? So therefore their individual probability is 1 by 3. Please keep a note of this formula as well. So all the important formula we have done. We are left with only one formula, and that is conditional probability, which we are going to take up after this. Conditional probability. Okay. So we have done the additional formula as well. So non-mutually exclusive, PA plus PB minus P intersection B. For mutually exclusive, simply PA plus PB, and ABC will be equally likely when PA is equal to PB is equal to PC. And for if A and B are exhaustive events, that means together they have to be 1. So union B, A plus B is 1. Okay. So this is basically what the formulas in the study material also 16.10, 16.11, 12, 13 and 14. Fine. Now we take example 16.8. I will move to example 16.8. Request you to please move to 16.8. Let's see the formula the question 16.8. Let us see the example and see what the question says. 16.8. The question says, 3 events A, B and C are mutually exclusive. Okay, very good, mutually exclusive. That means one of them has to occur. If A occurs, then B cannot occur. If C occurs, then A and B cannot occur. Fine. So A, B and C are mutually exclusive. They are exhaustive, which means together the probability is 1. So it is exhaustive also. And equally likely. Okay, equally likely, EL. What is the probability of the complementary event of A? So we know that the complementary event of A is called PA dash. You have to find out PA dash. Lovely problem. It's a lovely problem. You have to find the probability of PA dash, the complementary event of A. Well, fine. Please see the problem once again. First of all, A, B and C. 3 events. A, B and C. They are mutually exclusive, equally likely, and they are exhaustive. So I can say that P, A plus B plus C is nothing but PA plus PB plus PC. So the sum of their total is basically the sum of their individual probability. Number 1. Number 2, I can also say that since they are equally likely, I can also say that probability of A is equal to probability of B is equal to probability of C. And together they are equal to 1. That means each of them has the probability 1/3. I hope it is clear and logical to you. You are following and you are understanding. You are also keeping notes and performing the questions, answers with me, as I always request you in every session, right? Please do it with me. Just looking at the slide will not help you because you have to know and you have to also perform, right? Please continue with me. So each of them is equally likely. I think this is clear. So each of them has the probability 1/3. Very good. Now we can say that probability of A is 1/3. Then we have to find out probability of A dash. So the complementary event of A, what is the probability? Very simple, we know the formula 1 minus PA. PA is 1/3. So it is 1 minus 1/3, that is 2/3. So the answer is 2/3. This is example 16.8. Okay. I think you are clear. So we have seen that the relation of the events are given nicely. They are exhaustive, they are equally likely, and they are mutually exclusive, which means mutually exclusive means that if one of them takes place, the other cannot take place. Equally likely means each of them is equal to each other, and together they are equal to 1. So P, A plus B plus C is equal to 1 because they are also exhaustive. So using these 3 relations, we easily arrive at the individual probability of PA, which is 1/3. If PA is 1/3, then the complementary event will be 1 minus 1/3. That is, it is 2/3. Okay. Fine. Now we are taking up, let's take example 16.10. Okay. Let's take example 16.10. Okay. So we have covered problems on coin tossing. We have also done problems on cards, and I'm sure you are following and you are learning and getting more confidence to solve these problems. We take up 16.10. A coin is tossed three times. Okay. I think we have done this. Oh, this one is done. We have done this. A coin is tossed three times. What is the probability of getting two or more heads? This is done. So I will not do this. This we have already done in the first example. Okay, fine. Then let us take number 16.12. 16.12. Example 16.12. 16.12. Okay, just a moment. So let us quickly review up till now what we have we have discussed so far. We started with the basic understanding of what is probability. Okay. Then we saw what are the different industry applications. I talked about almost 10 to 11 industry applications to make you understand how practical this chapter is and how important it is to know probability, because without knowing probability, when we move to theoretical distribution, it will be very difficult for you to understand. So probability is a foundation, very important. Then we talked about, discussing about the minimum value of probability, which can be 0, which shows impossible event, and the maximum probability can be 1. That means it's a sure event, certain event. Then we discussed about who is the inventor. I talked about Laplace. I talked about, other leading, like Thomas Bayes, who helped in development of this important probability theory. We looked at the terms mutually exclusive. First we talked about what is experiment, what is event, or what is outcome. Then we discussed about different examples of experiments and events. We also talked about the different terms, mutually exclusive events, equally likely events, and you can also have exhaustive events. Thereafter we moved on to the formula PA plus B. What is the formula in case of mutually exclusive and what is the formula in case of non-mutually exclusive that we have seen and we have discussed. Thereafter we took up the concept of the a priori definition of probability, which says that the a priori definition says that the probability of any event is defined as a ratio of the number of favorable cases by the number of possible cases. Favorable cases means all those cases which are favorable to an event, plus they are mutually exclusive, exhaustive, and they are equally likely, and definitely the total number of possible cases also will be mutually exclusive, they will be exhaustive, and they will be equally likely. Then we moved on to discuss about complementary events, and I also discussed about odds, right? Odds in favor and odds against a particular event. I took an example. Thereafter we did example 16.1, 16.4, 16.8, and now we are taking up 16.12. I also did, then we will move on to conditional probability. Let's see 16.12. The question says the probability that an accountant's job applicant has a BCom degree is 0.85. So probability of a BCom is 0.85. Fine. 0.85. Please note, a probability that he is a CA is 0.30. So probability that he is a CA is 0.30. Fine. And the probability that is both BCom and CA is both BCom plus CA. What is the probability of this? It is 0.25. Now the question is, there are 500 applicants. 500 applicants are there, and you have to find out how many of them are BCom or CA. How many of them are BCom or, I am underlining or CA. Please see the problem once again. You have P BCom, probability of the accountant having a BCom degree is 0.85. So you see, this is, my dear friends, this is another example of events which are not mutually exclusive. Why? If you are a BCom, does it necessarily mean that you are not a CA? Or if you are a CA, does it necessarily mean you are not BCom? Right? So some CAs are also BCom. I mean, they definitely are commerce graduates, right? Anyway, most of the CAs are BComs. But there are some CAs who possibly have a science degree, for example, or they may have a degree in arts or economics, right? It's possible. But that means option number one is I am a pure BCom, only BCom applying for accountant's job. Event number one. The second event can be I am a CA and I am applying for the same job, but I am not a commerce graduate. I am a science graduate. The third possibility can be I am a CA applying for the job, but I am also BCom. So there are three outcomes possible. That is only BCom, right? It can be only CA or it can be BCom plus CA. Please understand. Lovely problem, unique problem. Thanks to Board of Studies. My appreciation to the experts in the Board of Studies in the mathematics department and the statistics department who have developed lovely examples. Okay. So if you look at this question, please also note that this is an example, further example of events which are not mutually exclusive. That means there can be a mix. Okay. So in this case, since they are not mutually exclusive, what is the formula to be applied? Right. So we know the formula to be applied in case of we have to find out BCom or CA. That means we have to find out the probability of BCom plus CA. This plus means or. You may remember this is like PA union B. So BCom plus CA. This will be what? The probability that you are only BCom plus the probability that you are only CA minus the probability that you are both BCom plus CA. BCom and CA. Here it is and. Okay. So what we do here is the probability that you are only BCom is 0.85. So we put here 0.85. Probability of only CA 0.30. So plus 0.30. And you are both BCom and CA. That means basically BCom and CA means BCom intersection CA. You are both BCom and CA. So this is 0.25. So it is minus 0.25. So let us see what this comes out to. This is coming to 85. Okay. It comes to 0.90. The probability comes to 0.90. So the probability that the accountant will be either BCom or CA is 0.90. Is it clear? Right? So please see once again, they are not mutually exclusive events. Since they are not mutually exclusive, we have applied this formula and we have arrived at 0.90 probability. We have used the formula PA plus PB minus PA intersection B. So we have taken the probability of only BCom 0.85. We have taken the probability of only CA 0.30 and we have subtracted the probability that they are both BCom and CA 0.25 subtracted. So we get 0.90. But now we have, the probability that a random person is either BCom or CA is 0.90. Very good. Excellent. But the question here is how many applicants will be there with such a background? Now we have 500 applicants. So the frequency, now I am using a statistical term frequency because all of you have understood what is frequency. You must have done histograms, polygons, frequency polygon, cumulative frequency. You know that. So the frequency of out of 500 candidates that the person is either a BCom or a CA, right, will be what? 0.90 into 500 candidates. So it comes to 450 candidates. Okay, so the answer is 450 is the expected frequency. So this is 16.12. Fine. Okay, there are some theorems. Up till now we have seen many of the theorems like this example itself is built on a theorem PA plus B or mutually exclusive events. Now if you see theorem 1, 2 and 3 I have already done, right? So basic theorem is PA union B or PA plus B basically that we saw is PA plus PB if the events are mutually exclusive. If the events are not mutually exclusive, then it is PA plus PB minus PA intersection B. Okay. Now we see theorem 4 which says that for three events A, B and C, what will be, if they are not mutually exclusive, right, then what will be the probability of P A plus B plus C? In other words, this is P A union B union C. From Venn diagram, you know the formula will be this: P A plus P B plus P C minus P A intersection B minus P B intersection C minus P probability of A intersection C plus probability of A intersection B intersection C. So this is theorem 4. Please have a look at this. I think this formula is now clear. This we have done earlier also in the chapter on sets, relations and functions. Okay, so P A plus B, there is also A union B union C, individual probability minus the common probabilities AB, BC, AC, plus we add the common parts of the three sets A, B and C. Okay, now we go to the last part, 16.8, which is on conditional probability and compound probability. Okay, conditional probability and compound probability. So we go to 16.8. 16.8 of the chapter, 16.8 of your study material. Now, what is, we take two further, we take two further examples: compound probability or joint probability, and what is, so compound probability, also called joint probability, and we will also take what is conditional probability. So first let us take what is conditional and compound. Okay. Fine. Okay. Let us take this. Compound probability means what? Now, say for example, there are two independent events. Now, independent events. Give some examples of independent events. Now, say you have a friend who's appearing for, BCom exam as well as for CA exam. Event A is that I'm appearing for BCom exam. Event B is I'm appearing for CA exam. Are they dependent? No, they are independent. Okay. Second example, today it is going to rain or not. Event A, possibility of rain. The second event is, say, whether I will study in the evening or not. Maybe I'm too tired after all these, classes, VCC, morning session, then within 1 hour afternoon session. So maybe you are tired. So the two events, event 1, raining today, and event 2, study in the evening. Are they dependent? No, they are independent event. They cannot have any common, no conditions which can bring them together. Okay, so they are totally, they're examples of independent events. Now, in case of independent events, please note a formula. When we talk of independent events, independent, I am writing just 2 days back we celebrated Independence Day. So here again we talk of independent events, right? Independent events. So P intersection B, in case of two events A and B which are independent, okay, the probability of P intersection B, that is PAB, is nothing but the product of the individual probability, PA into PB. Very simple. PAB is equal to PA into PB. That means what? If, let me take an example. Fine. Probability of rain. Okay. PR is, say in your locality, it is raining heavy. So it's already raining and you feel it's going to rain in the evening. Chance is 0.8, 80% chance, 0.8. Fine. Probability of rain is 0.8. Probability that you will study in the evening after digesting whatever you have learned, probability chapter and everything. So probability that you will study in the evening after learning probability say, I don't know, it will vary from person to person, but maybe say a 40% chance he will study. So probability of studying in the evening, PS, studying, is 0.4. Okay. So probability of rain and studying, are they linked in any way? I don't think so. Of course, some of you might say that if it rains, heavily, or if it rains, if there is a drizzle, I feel like watching the rain. Some of you may write poems. Some of you may start singing, right? But then definitely that is only, mathematically speaking, we cannot assume that. Mathematically speaking, yes, if it rains and if rain is an event and studying is an event, they are independent. Of course, but on a personal level, some of you may not study if it rains, or if it rains, you may feel like doing some artistic work or writing or singing or listening to some songs, movie songs, whatever. Right. But then in mathematical terms, absolutely there is no relation between them. So they are independent events. And in this case, if I ask you that what is the probability that it will rain and you will study? That means I'm asking for joint probability. I want to know the joint probability, compounding, right? Bringing together two events. That means I want to know probability of RS. That what is the probability that it is going to rain and you will study in the evening. So this will be equal to PR into PS. That means 0.8 into 0.4. That means 0.32. This is called joint probability for two independent events. Please note the events are totally independent. They don't have any connection. Please note, please apply your statistical sense and mathematical sense if you get such a problem. Like as I said, some of you may want to do some other activity when it rains other than studying. Maybe watching a movie or, spending time with your parents or with your siblings or with your friends, right? But that is not from mathematical perspective. From mathematical perspective, raining, which is a weather phenomenon, and studying, which is a personal phenomenon, may not have any connection. Therefore, they are independent. Okay. So, independent events, please note the joint probability or the compound probability is PR into PS, and this is what we get. This is a very important relation. Now, we come to the last part, and that is we look at what is conditional probability. Okay. Otherwise, the chapter is very interesting and not that difficult, but you get good number of problems, at least 4 problems you can expect from this chapter, looking at the importance given to this chapter. Now, we come to the second case, and that is what happens in case of independent events. For events which are independent to each other, we saw it's a product. Now let us see those events where there is some dependence. They are not independent. They have some connection with in between. So if it is purely independent, for purely independent events, PAB is equal to PA into PB. Please remember, for independent events. But for events which are not independent, they are not independent. Means what? Two events have some connection. That means if one event takes place, then only second event will take place. If I pass CA foundation, only then I can pursue CA IPCC. When I pass at least one group of IPCC, only then I can go for articleship. In CA, you know there is a system of articleship of 3 years. You can do it in a firm of chartered accountants. 3 years. And once, if I complete articleship, only then I can go for becoming a chartered accountant. I can become a CA provided I pass my CA final exams. So you see, these are linked. You know, it's like, again, you see, it's like just a staircase. It's a staircase. Okay, it's a staircase. So the question is, if I do not go to one particular level, I cannot go to the other level. level, if I go CPT, okay, foundation, FDN, foundation, then I will go to IPCC, then I will go to articleship, then I will become CA. Okay, step 1, step 2, step 3, step 4, all are linked. They are linked. Each event is dependent on the other event. To go for articleship means you must have completed your foundation. You must have completed at least one group of IPCC, otherwise you cannot go for articleship. They are dependent on each other. Okay, if you complete articleship, only then you can become a CA. There are cases, a person completes articleship of 3 years, but unable to pass CA final. He cannot be a CA, he or she. Another situation can happen. The person has completed CA final, but maybe his articleship is still pending. He cannot become a CA. So they are linked. These events are dependent events. They are not independent. Please note, they are linked. First level foundation, then IPCC, then articleship, then CA. Like a staircase. So I have drawn a staircase. Stairs. Now the question is, what happens in case of events which are not independent? In case of independent events, we have seen PAB is PA into PB. But what happens if the events are not independent? So let us see the last formula, a very simple formula, and with this we will go into the exercises and solve some of them. So we now write the formula for events which are not independent. This is called conditional probability. Okay, so I am writing, it is called, please note, it is known as conditional probability. And the formula is given by like this, PAB equal to PA multiplied by PB by A. So we will read it as this, like this, probability of the joint probability of A and B, or the compound probability of A and B, is equal to the individual probability of A multiplied by the probability of the event B, assuming that A has already occurred. Okay, the conditional probability of B assuming A has already occurred. So the formula is PAB equal to PA into PB by A. So I can also write it as this in this way, PB into P of A by B. The same formula I will get. So please note this and this one, both of them. This is called conditional probability, and it is the last formula, the last theorem which we are learning in this particular chapter. So please note PA intersection B or PAB equal to PA into PB by A. Conditional probability of B assuming that A has already occurred, and the next one is same formula, PB into P of A by B, that is conditional probability of A assuming that event B has already occurred. Okay, so these are, and also draw the staircase if you want. I was just trying to explain in common language, in simple words, what is meant by non-independent events. So the journey in CA is non-independent. Okay, so different things are there in any qualification. If you want to be a pilot, you have to complete your private pilot license, you have to then complete your ground classes, you then have to complete your simulator training, then you get your CPL. So conditional. Okay, so it's in the same direction. So if you want to be a doctor, you have to complete your house surgeon, you have to be a house surgeon, complete all the exams. So one is dependent on the other. Okay, so please note this is what is called conditional probability. Fine. Now we will take example 16.15 using this formula. 16.15. Okay. Example number 16.15. 16.15, let us see what the problem says. Okay. Rupesh is known to hit a target in 5 out of 9 shots. So if he fires 9 shots, out of 9 he will hit the target 5 times. This is the performance of Rupesh. So I will write probability that Rupesh, R for Rupesh, probability that Rupesh hits the target is 5 out of 9. 5 out of 9. That is, the probability is 5 by 9. Next is David. David is known to hit the target in 6 out of 11 shots. So probability of David, PD, is 6 out of 11. That is 6 by 11. What is the probability that the target would be hit once they both try? Okay. So once they both try, what is the probability that the target will be hit? Okay. Please see how to do this. Please think. Rupesh has the probability to hit the target. His probability is 5 by 9. David. Okay. David is having a probability of 6 by 11 to hit the target. Now the question is, what will be the probability that the target is hit once they both try? Which means either, David or Rupesh will be hitting the target. Target can be hit only with one bullet. So either of them. So in this case, PR, you have to find out PR union D. Okay. Now, my simple question to you, in this example, in case of independent events, in case of mutually exclusive events, that the formula of PR union D equal to PR plus PD normally. But here, is it that it is mutually exclusive? Mutually exclusive means either Rupesh will hit the target or David will hit the target. But here, there may be a probability that both will hit the target. Right? So, this is a case like this. In the Venn diagram, there is an intersection. If this is Rupesh and this is David, there can be a possibility that both are hitting the target. That means these events are not mutually exclusive. Please note, they are not mutually exclusive because mutually exclusive means either I fail or I pass. Either I hit or David, if I am Rupesh and I have David with me, if I hit or David hits. But there can be a chance that both can also hit simultaneously. Therefore, these two events are not mutually exclusive, which means since they have a common part, the formula to be used is PR plus PD minus probability of R intersection D. Okay? Please check whether it is fine or not. R intersection D. Now we see R intersection D. So PR intersection D. That means PRD. What will be the formula? We have just seen that if the events are independent events, then the formula of PRD will be simple. PR into PD. Here, Rupesh hitting the target and Rupesh and David hitting the target, are they independent? Definitely yes. Rupesh has no connection with David. David and Rupesh definitely can think independently and they can shoot. Rupesh will not be influenced by David. David is also not going to be influenced by Rupesh. They will apply their aim, they will apply their concentration, they will hit the target. Are you getting it? So Rupesh and David hitting the target, they are independent. If they are independent, the formula is this, PR into PD. So PR is 5 by 9 and PD is 6 by 11. So 5 by 9 into 6 by 11. This is coming to 3 3s, so 10 by 33. Now we put this value in this formula. So now we know PR is 5 by 9 plus PD is 6 by 11 minus PRD, that is 10 by 33. So if you work out, let's work out and see what happens. Just 5 by 9 plus 6 by 11 minus 10 by 33. If you solve it, you will be getting the value of 99 if you take. So 9, 11, 5 is 55 plus 954, that is 109 minus 30. So 79, I am getting the value 79 by 99. The probability is 79 by 99. Okay. So I hope you are clear with this. This is a lovely question, 16.15. Beautiful question because it tests two of the theorems. First theorem is what is the sum of two events R and D when they are not mutually exclusive. So we apply formula number 1, and then it also tests the second formula, that is PRD. And since R and D are not, they are not actually they are in this case they are independent, they don't have any connection, right? Therefore we apply the simple formula PR into PD, and here we work it out, we get the answer 79 by 99. Okay. Let's take last two examples. Let me go now to the last concept, and that is the concept of expected value of a random variable, and then we will take the questions. Okay. Expected value of a random variable. So I am taking the last part. This is 16.10. So 16.10 of your study material in this chapter. Okay, so we have done conditional probability, and we have also done just a quick check. Okay, 12 we have done, Theorem 4 we have done, 16.8 conditional we have done, 16 example 15 we have carried out. And now we go to the last part, that is expected value. Okay, expectation. Expected value. Okay, expected value. So, expectation, mathematical expectation. This you must have done also in, you will do in other chapters of statistics, right? And in case of expectation, it's very simple. Expectation of, say, I put it in this way. Say for example, the probability, here I will write probability and here I will write prize money. Okay, prize money. Now, say for example, if I have a probability of say 20%. Okay, so probability is 20% here, and then I have a probability of say 60% and right, put it 50 and 30. Okay, now say I have a 20% chance of clearing an exam, and if I clear the exam with a 20% chance, I will be getting a prize of 1,000 rupees. Now, I also, if I pass with a 50% chance, if I appear for the exam, and if I make it, then I will get say 2,000 rupees, and with a 30% chance, I will get 750. So what will be the expectation? Expected value of a variable or a random variable, that is sigma E, that is expectation, E sigma E, which is basically like EX. Expectation of X, EX is equal to sigma Xi Pi, where X is the value of the variable and P is the probability. So it is nothing but the multiplication of the value and the probability. So in this case, the probability is 20%, I will get 1,000 rupees. Second case, probability 50%, I will get 2,000 rupees. Third case, probability is 30%, I will get 750. Okay, so in this case, the total expectation will be 20% means 1 by 5 into 1,000 plus 50%, that is half into 2,000 plus 30%, that is 3 by 10 into 750. So this gives me 1,000 into 1 by 5, that is 200, plus 2,000 by 2, that is 1,000, plus 3 by 10 into 750, that is 225. So it gives me 1425 rupees, of course. This is my total mathematical expectation shown by the formula sigma XIPI, where X is the value 1000, 2000, 750. P is the probability. So P is the probability. P is 1/5, half and 3 by 10. So this is called the mathematical expectation. Please keep a note of this particular formula, mathematical expectation. So this is expected value of a random variable, and this is how we arrive at the formula. Okay. Now we go to two small, cases. So please keep a note of this expectation. And now we look at two simple formula. The last part. Now, if you have expectation of a constant, okay, if there is a constant, expectation of a constant, that is expectation of a constant, right, is always equal to the constant itself, number one. Expectation of two events, say Ex plus Y, Ex plus Y will be equal to expectation of X plus expectation of Y separately. So first formula, second formula. Similarly, Ex minus Y will be Ex minus Ey, and the third formula is Exy, X multiplied by Y will be equal to the product of Ex into Ey. Okay, so expectation of a constant will be the constant. Expectation of the sum of two events, X plus Y, will be the sum of the individual expectations, and Exy, X multiplied by Y, is equal to Ex into Ey. So these are the last three formula, and we will solve the last example, and that is example number 16.29. Let's take 16.29, and then we will take the questions from the exercise. So I am taking the last example for explaining 16.29. Let's take 16.29. Number of examples, lovely examples are there so that you can work out and understand. In a business venture, please see the question. In a business venture, a man can make a profit of 50,000 or incur a loss of 20,000. Fine. So either you can get a profit of 50,000 or a loss of 20,000. Okay. The probability of making profit is 0.75. Probability is 0.75, and the probability of making loss is 0.25. What is his expected profit? So you can understand what is the expected profit. That is, here expected profit EP is equal to sigma xi into pi. That means first xi is how much? 50,000 into pi. Pi is 0.75 plus he has a loss of 20,000. Please note, kindly note, loss of 20,000. That means it is minus 20,000. So I will write minus 20,000 into pi 0.25. So let us see how much it comes. 50,000 into 0.75 plus 0.25 into minus 20,000. If you work it out, it is coming quickly. Let me see. It is 32,500. So his expected profit works out to 32,500. So you have expectation means the product of the probability and the value. XIPI, the value into probability. Okay. So everywhere we have taken value and probability, and sigma means what? We are adding up. This plus sign, this means sigma. We are adding up. Okay. So just by multiplying the probability and the given value and adding up all the similar cases, you can find out the mathematical expectation. Okay. Now let me take few questions. I am first going to exercise 16, set A. We just have a look at the time, 4:15. So expected to complete at around 4:30. Okay. We are taking set A. I am taking few questions from set A. So please move to exercise 16, set A. We have done all the formula, including conditional probability, joint probability, compound probability. We'll take up the questions now. Exercise 16, set A. I am taking I'm taking number 50, 50. Exercise 16, set A. Number 50, 50. ABC are three mutually independent events with probability is A's probability is 0.3, B's probability is 0.2 and C's probability is 0.4. What is the probability of P, A intersection B intersection C? Question number 50. Very simple. In case of events which are, it is given that they are mutually independent. They are independent. So this will be equal to the product of their individual probability. PA multiplied by PB multiplied by PC. So just a product of 0.3 into 0.2 into 0.4. So this should give you 0.024. Okay. So it's a simple question of independent events. They are mutually independent events. So we apply the product formula and we arrive at the result 0.024. This is number 50. I will take number 46. 46 is an interesting one. 46. So in the examples we are taking set A, B and C, 50, 46. Let's take 46. Probability of getting a head when two unbiased coins are tossed simultaneously. So you are throwing, two unbiased coins. What is the chance of getting a head? What is the chance of getting a head? Okay. So when you are throwing two coins, what is the sample space? Two coins. So the sample space, what can be the options? It can be head-tail, it can be tail-tail, it can be tail-head, and it can be head-head. Okay. So two chances, two coins are tossed, four cases can appear, and the question is probability of getting one head. So one head will be there in this case and one head is there in this case. That means my total number of possible cases is 4 and my total number of favorable cases is 2. So my probability is 2 by 4, that is half. Okay, I hope it's clear and you have followed. 46, good question. Now we take up 51, question number 51. Take question number 51. 51. If two letters at random are taken from the word home, H-O-M-E. So I think many of you will become nostalgic and you will think of the chapter permutation and combination which we completed some time back. Even I am feeling bad because I love that chapter permutation combination, but good that we are able to apply that and solve this question. If two letters are taken at random from the word home, what is the probability that none of the letters would be vowels? Okay. How many vowels are there? So we have two vowels. Two vowels and we have two consonants. Fine. Now, the letters will not be vowels. First of all, in how many ways two letters are taken? So you have 4 letters. In how many ways can you pick up 2 letters? That means how many possible cases are there? Possible ways of selecting 2 letters from H-O-M-E, from 4 letters is 4C2. Okay. 4C2, I hope you have not forgotten. I'm sure you have not forgotten. 4C2 is factorial 4, 2 and 2. So that comes to 3 into 4 by 2. So it's 6. Okay. So possible way 6. So denominator is 6. Now the question is, both the letters will not be vowels. That means they will be consonants. In how many ways can you pick two letters from two letters? There are two letters, H and M, which are consonants. They are not vowels. You have to pick two letters. In how many ways can you do it? 2C2. 2C2 is factorial 2 and 2 minus 2 is factorial 0, which is 1, which is basically 2. Factorial 2 by, NCR, so it is 2 and 2 minus 2 is 0. So 2 cancels out, it's 1. So you have the probability is equal to denominator 6 and numerator 1. So the answer is 1 by 6. So if two letters are taken at random from the word home, the probability that none of the letters would be vowels. That means they have to be consonants. Okay? This probability is given by 1 by 6. Fine. Now let's take 53. Question number 53. Okay. So it's a fairly big chapter, right? So many examples and lengthy chapter, right? But not that difficult, I hope, and it's quite interesting. And I always feel it's very practical for us as a professional chartered accountant and being a management consultant with so many companies. I feel it helps us. This concept helps us to work effectively in diverse assignments. So let's take 53. If x and y are random variables having expected values of expected value ex is 4.5. Expected value of y, ey, is 2.5. We have to find what is the expectation of ex minus y. We have done this formula a little while back, right? You know that ex minus y is simple. It is nothing but ex minus ey. So in this case, it is 4.5 minus 2.5, that is 2. My answer is 2.0. Okay? Simple expectation formula. We know expectation, mathematical expectation is the product of the sum of the amount involved, monetary amount involved, multiplied by the probability. And here we also know that ex, the formula you know is ex plus minus y is equal to ex plus minus ey. Simple. That's how we have done it. So 51 and 53 we have done. We now take up 54 also. Okay. 54, and then we will move to set B. We take 54. I'm taking the most difficult ones towards the end, because the ones which are in the beginning are relatively easier ones. 54, if the variance of a random variable, you have done variance, standard deviation. If the variance of a random variable, you know variance is nothing but standard deviation sigma square. That is variance. Okay? Standard deviation is shown by sigma. All of you know. And variance is nothing but the square of the standard deviation. Now, if the variance of a random variable x, the variance is 23, then what is the variance of 2x plus 10? Okay, so if y is equal to 2x plus 10, what will be the variance of this expression? Now, you know already, you have done, I am sure, standard deviation, measures of dispersion, and you must have been taught about this formula, and you must be knowing that when you have this type of expression, the formula will be that we have to find out what is the variance of y, that is 2x plus 10. Here, it is basically a plus xb, bx. This is of the form a plus bx, and here b is 2. B is a constant, b is 2. So in this case, the variance of y, var y, will be equal to the variance of b, of x, variance of x, into b square. So b square into the variance of x. Right? Now, here b is 2. A plus bx, 2x plus 10. So variance of y will be equal to b square, that is 2 square, into variance of x. Variance of x is 23. So this is 4 into 23, that is 92. Okay? This is how we arrive at 54. Right? This is based partially on your understanding on the chapter of dispersion and also from the probability. It's a summation of both. Okay. Taking up the last one, 55 in this set, 55. 55, question number 55. 55. Question 55. What is the probability of having at least 1/6 from 3 throws of a perfect dice? A die is thrown 3 times, once, twice and thrice. What is the probability of having at least 1/6? At least 1/6. So 3 times the dice is thrown. And you need to find out at least once. It should be 6. At least 1/6. At least 1/6. Okay, that is basically what we need to find out. So, simple technique of finding the probability in this case is the probability is equal to at least 1/6 means what? The complementary event is, if I say at least 1/6, the complementary event is that no 6 will come. Okay, that means probability will be 1 minus the probability that no 6 will come. Probability that 6 will not come, no 6 will come. Okay, how would you do it? Die has 6 surfaces, a cube, 6 surfaces. Now, what is the probability that you will not get 6 when you throw the die first time, once? What is the probability that you will not get 6? It is given by 5/6. Again you throw the dice, again, second time. What is the probability you will not get 6? That means you can get 1, 2, 3, 4, 5, but you will not get 6. That means 5/6 again. Again 5/6. Third time you throw, same outcome, 5/6. So the answer is 1 minus 5/6 cube, whatever this comes. Right? So I think this will come to 1 minus 125 by 216, and then you can simplify and see what is the answer. So with this we complete set A. I will take up just 2-3 problems of set B. Or let me do one thing. Let me take MTP problems. If you see CA May 2020 MTP problems, question number 81 and 82. MTP 81 and 82 I am writing. MTP May 2020, 81 and 82 I have already solved. You can see the same questions are there, which is there in the study material. One question is on the cards, right, back of cards, and the other one is what we did, probability of the complementary event of A. 81 and 82 already we have done. 84, which is also there, I have done. 84 was the accountant job and the BCom degree. You may remember BCom CA, right, which was a question of probability which we did. And then 85, if you see, this problem we have just done, because this question is the question Rupesh is hitting a target and David is hitting a target. This also I did. So MTP we have done all the questions which came. I will just take set B. Let me take up set B. Let me take up number 15. Okay, let's take number 15. Set B number 15. Set B number 15. Please go to set B. MTP we have done. MTP all questions we have done. 15, if for two independent events A and B, it is given that PAUB. PA is given 2/5. You have to find PB. PB you don't know. Okay. So you have to find what is probability of B. You are given PA plus B and you are given PA. Now you know that PA plus PA union B is equal to PA plus PB minus PAB. This we know. Now it is given that two independent events A and B, right? So two independent events it is given, right? So from here you can understand this is nothing but PA plus PB minus PA into PB, because they are two independent events. So PAB is equal to PA into PB. If I put the value of PA now, what do I get? 2/5 plus PB minus 2 by 5 into PB. This is equal to 2 by 3 which is given. This is my equation. From here I am getting 2 by 5 plus PB minus 2 by 5 PB is equal to 2 by 3. That means PB, I am taking common, 1 minus 2 by 5 is equal to 2 by 3 minus 2 by 5. Transposing this on the right hand side. If you solve for it, you will be getting PB, probability of B. You will be getting PB, so this will be 15, 3, 5, 10 minus 5, 3 2 are 6. So it is 4 by 15 on the right hand side, and here you have P by B into 3 by 5 equal to 4 by 15. Okay, so PB will be equal to into 5 by 3. So 4 by 9. My answer is coming to 4 by 9. So PB is coming to 4 by 9. Question number 15, PB, my answer is coming 4 by 9. So you can see it's a simple formula. PA plus B, PA plus PB minus PAB. Since they are independent, we put PA into PB. PA value is given 2 by 5. So I am putting PA equal to 2 by 5. From there, the equation comes and we solve the equation. So 15 is done. I will take another one. Let's take after 15. Okay, let's take number 21. Okay, let's take number 21. This is on expectation. So let us take number 21 on expectation. 21 on expectation. Okay, trying to do as many as possible, winding up in another 5 minutes. 21. If a random variable x assumes the value 0, 1 and 2, fine. With the probability of 0.3, 0.5 and 0.2, then what is the expected value? Simple. So we know Ex equal to sigma xi into pi. That means here 0 into 0.3 plus 1 into 0.5. 1 into 0.5 plus 2 into 0.2. 2 into 0.2. So this gives me 0 plus this gives me 0.5 plus this gives me 2 2s are 4.4. Okay, this is coming to 0.5 and 0.4, that is 0.9. My answer is coming to 0.9. Please check it. This is number 21. Okay, so this is set B, number 21. Okay, and number 21, and we have also done number 15 and 21. Okay, now we take up the last one, set C, and I will take up set C. I will take up, let me take number 12. Okay, set C, number 12. The last problem for today. Okay, set B, set C, number 12. Set C, number 12. Okay, this is a question. Tom speaks the truth in 30% of the cases. Okay, so Tom speaks truth in 30% cases. So for Tom, it is 0.3. Dick, D, speaks truth in 25% cases, 0.25. What is the probability that they will contradict each other? What is a lovely question. Thanks once again to Board of Studies. That's why I picked this question specifically. Tom's probability of speaking the truth is 0.3 and Dick's probability speaking the truth is 0.25. Yes, hello. Hello. Yeah, I'm just completing in 2 minutes. Just give me 2 minutes. Just completing. Okay, just 2 minutes. Fine. Okay. So, Tim, in case of Tom, it is 30%. In case of Dick, it is 0.25. So, the probability they will contradict each other is very simple. That means if Tom speaks the truth, Dick will not speak the truth. And if Dick speaks the truth, Tom will not speak the truth. So, first I will assume that Tom is speaking the truth. 0.3. But Dick will not speak the truth. Dick will say something false. Probability of speaking truth is 0.25. So the probability that Dick will give a lie, he will lie, is 0.75. Plus, now this time we are assuming Dick is speaking the truth, but Tom is going to lie. Tom speaking the truth, probability is 0.3. So the probability that Tom will lie is given by 0.7. 1 minus 0.3. And this time Dick is going to present, will speak the truth. His probability is 0.25. So if you add it up, 0.3 into 0.75, sorry, plus 0.7 into 0.25. So if you add it up, I think it will arrive at 0.4. Finally, it will come to 0.4. Right? So 3 by 10 into 75 by 100 plus 7 by 10 into 25 by 100. It will give you 0.4. So dear friends, I think we will complete here. We have talked about probability definition. I have given you details of industry applications of probability, the business applications. Then we looked into probability concepts, mutually exclusive, exhaustive, equally likely. We did number of examples from the solved examples, number 1, 4, 8, 12, 15, 29. Then we looked at more than almost 12 to 14 problems we have done comprising set A, set B and set C. I discussed about the conditional probability, looked at all the theorems, and we also did mathematical expectation, which is the product of the monetary amount multiplied by the probability of occurrence. And then again, as usual, problems from the exercise as well as May MTP 2020. All the problems, I give you the numbers also here, which we have already done. And with this, I end up today, and make sure once again, the key takeaways from this chapter is that be sure to work hard so that the probability of your passing CA foundation is not going to be less than 1. You have to make it, and you will definitely do it with hard work. See you next day, and we will take up theoretical distribution on that day on the 19th. Till then, thanks to ECPL team and thanks to each one of you for joining, and wishing you the very best. Work hard so that you get success. Thanks for now.